Hi, this is Alex from devstories.eu. Snowflake and Snowpark Python, episode 16 of 17. How do you process gigabyte-sized unstructured files inside a user-defined function without blowing up your memory limits? If you try to map large files as static dependencies, the system attempts to download everything up front and your code crashes. The solution to this is dynamic file access with SnowflakeFile. To understand why this matters, look at how file access normally works in Snowpark. Usually, you use the imports parameter to bind a file to your function. This static approach is great for small configuration files or a specialized machine learning model because the file is pulled down to the compute warehouse before execution begins, but it falls apart at scale. If your pipeline needs to process hundreds of massive server log files or high-resolution PDFs stored in a Snowflake stage, downloading them all statically is incredibly slow and guarantees an out-of-memory error. This is where the SnowflakeFile class comes in. Located in the snowflake.snowpark.files module, this class allows your function or stored procedure to open files directly from a stage at runtime. You do not bind the file during the function creation. Instead, your function accepts the location as a standard string argument. When you call the function in your SQL query or data frame operation, you pass in that location. Inside the Python code, you call the open method on the SnowflakeFile class and pass it the file location string. You also specify the read mode using standard Python conventions like R for text or RB for reading bytes. Here is the key insight. Calling open does not load the file. It yields a file-like object that streams the data. The file stays on the stage and you pull the data through a network pipe. Let's apply this to the log processing scenario. You have a database table where each row contains a scoped URL pointing to a different large log file on an internal stage. You pass that URL column to your function. Inside the function, you open the stream and write a standard loop to read the file line by line. As your code evaluates each line to extract error codes or timestamps, Python discards the previous lines from memory. You can parse a 50 gigabyte log file while your function only ever holds a single line of text in memory at any given millisecond. The exact same concept works for binary files. If you're extracting text from large PDFs, you open the file in binary mode and pass the resulting stream directly into a Python PDF parsing library. The library reads the byte stream sequentially without requiring the entire document to reside in system memory. SnowflakeFile also handles the security boundary automatically. When you pass a dynamically generated scoped URL into your function, Snowflake grants read access to that specific file just for the duration of the query, expiring immediately when the query finishes. Streaming dynamically specified files keeps your memory footprint flat regardless of the file size, letting your compute warehouse focus entirely on processing the data instead of just trying to hold it. That's all for this one. Thanks for listening and keep building.